This is the TMUA from 2023, paper number one. Let's just do it. First one's a nice little simultaneous equation. Of course, once you integrate this, you get this, and you can put in 1 and 0. Putting in 0 just makes everything 0. Putting in 1 just gives you the coefficients, which is very nice. Double everything, you get this. Do the same thing over here. Maybe after you expand out the x first, you end up with this. Again, the 1 and the 0 do the same thing. Times everything by 6, maybe. And you end up with this. Double this one, and then take away. And you should end up with something like this, which then gives you A is this, and the sum of A and B is this. Nice little warm-up question, done. The graphs this and this are plotted, and they do not meet, so the discriminant is less than 0 then. So let's just set this equal to this, and rearrange. Rearrange like this, so you can get a B from here, and A, of course, is 1, and C is 9, so B squared minus 4AC needs to be less than 0. At this point, I decided to be super fancy because I was bored. This can be written as 6 squared. This can be swapped over because when you square something, it's the same as squaring the negative of it. And then this is a difference of two squares, so it ends up being like this. And if we're less than 0, we want to be in between the two roots, right? The roots being 11 and minus 1. So we're going to want to be this one here of A. Excellent. Number 3. So we have this nice little rule for this particular function. So um, what we need to do is when we look at these ones here, we just need to make them follow the rule. So we need n to be an integer. We need n and n plus 1 here. Well, this doesn't have that, but I can make it have it by going from 0 to 1, then from 1 to 2, then from 2 to 3. So I'm going to break that down into 3 different integrals, doing all of those things. And likewise, these ones are just upside down, so I can make those negatives, which I think I'll do first. So I'll just make those negatives to swap those over. And now I'm going to do what I said, which is split that one into 3 integrals to make it all have 0 to 1, 1 to 2, 2 to 3, so it follows this rule. And likewise with this one, these two are okay already. And then likewise with that one there. Now just replace those all with the rule here, which is this one is n is 0, so that just becomes 0 plus 1. This one n is 1, so it becomes 1 plus 1, and so on. And if you add all those together, you'll end up with the answer of 1. With these kind of questions, just do some simple evaluating for the first few terms and just see what happens. So I put in n is 0, then n is 1, then n is 2, and so on, and you got this. Now notice that sine of pi over 3 is the same as sine of 2 pi over 3, because it's just moved 2 pi forward, and sine is periodic every 2 pi. So likewise, when you move another 2 pi forward, this will be the same as well. So this, and this must be the same. But likewise, this and this must be the same for the same reason. You're moving up 2 pi. So that's the first thing I'll say. Also, you can, so that's just what I've said there. And I've made this one 4 pi over 3, right? And so likewise, this one is as well. But now, if you actually look at the sine graph, sine of pi over 3 is root 3 over 2, right? But I don't really care about that much right now. So pi over 3 is somewhere like here, right? Root 3 over 2, something like that. What I really care about is sine 4 pi over 3 is symmetrical on the other side, and it's just minus root 3 over 2. So essentially, I can just write this one as minus sine pi over 3, and this is minus sine pi over 3, and so on. And so now I can factorize out the sine pi over 3, which is root 3 over 2, and just leave behind 1 minus half plus a quarter minus an eighth plus 16th, and so on. This is a geometric sequence with a1 and r minus a half. So if I put it into the formula, it looks like this for the sum to infinity. This is 3 over 2, which flips to 2/3, which cancels to make root 3 over 3, will be our answer. Number 5, so perimeter 40 means this is length 10. If I just call this length x, because that's what they told me, then this is 10 minus x. And now, just thinking about the 1, 1 root 2 right angle triangle, this triangle is x, x, x root 2. And likewise, this one here is 10 minus x, 10 minus x, root 2 into 10 minus x. And so these two things times together apparently to make 20, because that's what the area of this rectangle is. So they times to make 20, these to make 2, so then we can just divide by 2 to make this, expand it all out and collect, and you get this. And you solve that, maybe just implementing the square or some formula, it doesn't really matter. You get this. The largest value of that is, of course, 5 plus root 15. So our answer is F. And number 6, then, really nice question. I just immediately looked at it and thought that's really nice. 12 is 2 times 2 times 3. So for any number to be divisible by 12, it must have 2 2's and a 3 in it when written in prime factor form. Now, the first time this expansion is 2 to the power 12, which doesn't have a 3 in it. So obviously that's not divisible by 12. The next term is 12 choose 1 times 2 to the 11 times 3. But of course, because there's a 12 right here, this is obviously going to be divisible by 12. It's also got 2 2's and a 3 right here, so it's absolutely fine. This will work. The next one is 12 choose 2, which is 12 times 11 divided by 2. Times 2 to the 10 times 3 squared. Now, this is actually, because the 2 cancels this is not divisible by 12, but it doesn't matter. Like I said, all we need for something to be divisible by 12 is 2 2's and a 3. And we can see from the pattern that the 2's are going to give us and the 3's are going to give us that we're always going to have two 2's and a 3 all the way down to this term here. So every single term down the 2 to the 9, 2 to the 8, and so on with the increasing 3's, they're all going to be divisible by 12 because they have two 2's and a 3 in them. The choose functions don't matter until you get down to here when you've only got one 2. However, by the time you get down to here, you've got 12 choose 11 to do, and 12 choose 11 is just 12, and so therefore this number is divisible by 12 because it's got a 12 right there. And then the very last one is just 3 to the 12 with 12 choose 0, I guess, which is just 1, like it was up here. And that's not got any 2's in it, so that doesn't work either. There are 13 terms in this, and 2 of them don't do it, so therefore 11 of them do. Question 7, we just need to say that P and Q are equal to 4 to 1. So therefore, you could think if you times Q by 4, you get to P, or just do P over 4 equals Q over 1. I always just teach that left over left equals right over right. And now, of course, if you times out the 4, you get what I said the first time, which is just this. But now, of course, we can just deal with this. Now, this is 2 to the 2x over 2 to the 2, and this is 2 squared times 2 to the x because you add the powers when you multiply, so it makes this kind of thing. And likewise here, you take them away when you divide. But this is just 4, so that cancels there. And this makes a 16, I guess. And now we can start putting everything on one side. This is essentially just a quadratic. So it factorizes to this, I think, because this is like 2 to the x all squared, I guess you could write it as, which I just couldn't be bothered to do. Anyway, we get the answers of 2 to the x equals 12 or 2 to the x equals 5. The larger of those two things is definitely going to be, we'll look at the larger one, definitely going to be log to base 2 of 12. So that will be our answer. Let's just draw this. So this is a fun triangle. It seems pretty obvious that you can do sine rule on this. So sine 30 over a equals sine, let's just call this y, over root 3 over a. The a's obviously cancel. Sine 30 is a half, so this makes sine y equals root 3 over 2, which has two solutions, of course. Either y is 60 or y is 120, just doing symmetry around that 90 point on the sine graph. Draw the sine graph if you need to figure that kind of thing out. Now we have our two solutions for y. Let's just draw the two triangles, and we can work out the third angle, right? This one here is going to be 90, and this one here is going to be 30. But the area of this triangle, if that's 90 degrees, is just a half times a root 3. And the area of this triangle, if that's 30, is a half times a root 3 times sine of 30. But if you're doing the ratio of the area of this area to this area, all of this will just cancel with itself, and you just end up with 1 to sine 30, which is 1 to a half, which is the same as 2 to 1. And so the ratio is going to be 2 to 1. For number 9, then, we just need to square both sides. Remember, we have a plus 2 or a minus 2. We can rearrange both those to make these two things. And now for 3 theta, of course, we just need to triple this range to make this. And so draw the cos graph, and just bear in mind you're going to 540, and 540 is 180 past this. So it's going to come all the way down to the bottom again and stop at the bottom. Now, equals to 1/3, that's just a line across here. That's clearly going to have 1, 2, and 3 solutions when it meets there. And minus 1 is going to have just the 1 solution here, and the 2 solutions exactly at 540, which is allowed, and so therefore we'll have 5 solutions in total. Question 10 then. So you can get into a right pickle if you try and actually integrate this. The correct substitution would be something like 2 sine theta, or x equals 2 sine theta, or something like that. Sorry, no, u equals 2 sine x, of course. No, I was right the first time. What am I talking about? Anyway, regardless of that, you're just going to completely ignore that. What you're going to notice is if you set y to equal this function here, square both sides and rearrange, it's just a circle. So the area between minus 2 and 2 is just the area of the top half of a circle, radius 2, which is pi times 2 squared over 2, which is 2 pi. It looks like this, right? This is what this graph looks like. Because, of course, it's only the plus version of the graph from here. It's not the minus version. The minus version collects this bit up. But that doesn't matter. We're just looking for pi times 2 squared divided by 2 for this area here. That's the whole area. Now, if you're doing trapezium rule, you're going to estimate that into 4 parts, which look like this. You're going to, of course, put lines. Of course, this is 1 and minus 1, and then you can work out if x is 1, then y is, of course, root 3. I'm going to put some lines in there, and now I can just work out these two areas and double to get the full area that the trapezium would estimate. So, okay, well, this is just going to be root 3 times 2 times a half, which is root 3 over 2. And this is going to be 2 plus root 3 divided by 2 times 1. So yeah, that's that. And then, of course, the whole area will be this plus this doubled. Sorry, this plus this doubled, because there's both sides. The 2's all cancel, you end up with this, and the answer will be this minus this, which looks most like this one when you factorize out the 2 that way instead. For number 11, then, we have this curve here, which has a minimum point at minus 3, 9, I believe, or sorry, positive 3, 9, of course. Now, if you do this transformation, that squashes the graph in by factor k towards the y-axis. So the new minimum point will be 3 over k, comma minus 9. for example, if you put a 2 here, this squashes in factor 2 and this becomes 3 over 2. So that's where I get that from. And this moves the graph to the right by c, so it becomes 3 plus c minus 9. And apparently for these to have the same minimum point, we just, of course, need 3 over k to equal 3 plus c. Just bounce the 3 up to the top of the other side, and you get this, which will be our answer of B. For number 12, of course, write this 2 as 2 squared first, and then you can multiply out this bracket by just timesing. Now, of course, we just need this to equal this if the ratio between them is 1. And now, of course, we just need tan squared to equal 2 sine squared. Tan squared is sine squared over cos squared. And now we can cancel the sine squareds as long as we say sine squared of x equals 0 is a solution, which it could be. Of course, that happens a couple of times. Does it have yeah, it happens a couple of times, right? Well, actually, it happens 3 times, right? 0, pi, and 2 pi. But then, of course, we also have 1 over cos squared equals 2. So we can rearrange that to make this. And that's when we square it, can be plus or minus a half. And that's going to happen 4 times, because, of course, it's going to happen twice to get plus 1 over root 2 and twice to get minus 1 over root 2, because cos does the entire thing between 0 and 2 pi. So that's going to be 4 times over there, and we'll have 7 times in total for the number of solutions. Now we just need to draw these graphs. This is circle radius, sorry, center 2, 1, radius 4. So I guess it looks a bit like this. And this is circle center 4 minus 5, also radius 4. Now you can very quickly work out that the two centers here are 2 squared plus 6 squared apart, which is root 40 apart, which is bigger than 4. So this center is outside of this circle. And radius 4, of course, looks like this. It's going to be tangent to the y-axis because distance 4 here. And this should be the picture. Now, what's the maximum like PQ? If P is some point on here, Q is some point there, we'll just draw a line there, and then P will be this point, and Q will be this point for maximal distance. Distance is, of course, 4. It's the radius of the circle. Distance is 4 down here. The distance between the two centers, I've already said, is root 40, because it's 2 squared plus 6 squared, which is 2 root 10, and you just add those things together. You get F as your answer. For number 14, we have this function here, 3 distinct real roots. So for a cubic to have 3 distinct real roots, you need one of the stationary points to be above the x-axis and one to be below. If they're both above, then it will only have 1 real root, and if they're both below, it will also only have 1 real root. So we want 1 above, 1 below. Now the stationary points of this are, of course, found by differentiating and setting to 0. We can factorize that, and we have stationary points x equals 0 or x equals minus 2m. We can put those 2 points into the original function to find out where they are. If you put in 0, you, of course, just get n. And if you put in minus 2m, you get this, which eventually simplifies to this. Now, again, remember what I said. I needed one of these stationary points to be above the axis and one to be below for 3 roots. Now, notice that m is defined to be positive, which means that this thing is definitely positive, which means that this can't be the basically, it means n can't be positive, right? Because if n was positive, then, okay, then this is the positive root. This is the one up here. But then this would be positive too, because this is positive and this is positive because m is positive, and that doesn't work. So n must be negative, and therefore this is the negative root and this is the positive one, but then we also need this to actually be positive. So in other words, we need this whole thing to be greater than 0, because that one's the one that's less than 0, and we can rearrange that to get this. And so n has to be less than 0, but bigger than this thing here, and that makes our answer of A there, I think, and we're done. So this one's kind of an interesting question. We need to be a bit careful with these exponential graphs here. Now, if A is a positive number, which is helpful, because otherwise this doesn't work. We can't raise negatives to fractional powers and stuff like this very easily most of the time. So, okay, the problem is that this has 2 distinct cases to it. One where A is bigger than 1, and one where A is less than 1 and between 0. Now, if A is bigger than 1, like if it's 2 or 3 or whatever, the biggest this thing can be is, of course, a to the 1 when cos is at its max of 1, and the smallest it can be is a to the minus 1 when cos is at minus 1, right? However, if a is between 0 and 1, then that swaps over, because if a is between 0 and 1, you can almost write it as 1 over something, and then the minus power will flip that over and make it bigger as if it was something bigger than 1, and likewise the reverse for the minimum, right? But another way to think about it is if a is like a half, when you raise that to power minus 1, you flip over that to make 2, and then of course you just have a bigger number of 2. And also, like if you're raising things to half powers and you're a half, that makes it bigger, right? The square root of a half is 0.7 or whatever. So they've got these 2 cases here. So okay, the difference between them apparently is 3. So we've got 2 cases. Either this minus this is equal to 3, in which case we can times by a and solve, and we get this. However, we don't actually have 2 answers here, because this has the condition that a is bigger than 1. So we can't be 3 minus root 13 over 2 because that's not bigger than 1. So we have this solution here. But we also have the other case where actually it's going to be a to the minus 1 minus a to the 1 because the difference between the maximum and minimum is going to be now this minus this, right? So, and that's equal to 3. So now we do the same thing and we end up with this. But again, only one of these things is between 0 and a 1, and that's the plus case, of course. And these are our two answers for a, which if we add together, the real parts, sorry, not the real parts, the non-irrational parts will cancel out, and we'll just end up with root 13 over 2 plus root 13 over 2, which is root 13. Kind of an interesting question, kind of also quite difficult to think through, I guess. Another question you just have to be careful of here, draw it out, you get this. And now, of course, think about where you could put 5. Now, 5 is, of course, between 2 and 9 somewhere, so it's along like a line existing here. I thought the most obvious place to put it would be something like this, whereby if you draw a line connecting your original 2 points, you can have a right angle being made with this one and a right angle with this one. I thought that was the most obvious place to put it. Of course, the gradient of this line is minus 4 over 7 because just rise over 1 between these two, which means the gradient of this line needs to be 7/4. I've done this very quickly, but if you put in 2/3 into y minus y1 equals mx minus x1, you end up with this. I'm not going to bother actually doing that. I'm sure you guys can work this out. And then if you put in 5k, you end up with k equaling this. I've only put it in decimals because I've noticed the answers in decimals. Same thing down here. Gradient is still 7/4 because it's perpendicular to this gradient. Put in 9 minus 1, you end up with the equation this line is this, and then put in 5k, you end up with this here, which is, of course, this. Okay, so those are two answers here. Now it says find the sum of all possible values of n. This, for some reason, triggered my spidey sense. All the possible values. It seems unlikely they would use that wording if there were only 2 of them. And if you think it through a bit more carefully, you can find more of them, right? If you center a circle around these 2 original points, the center of this circle will be, of course, the average of 2 and 9 is 5/5, and the average of those 2 is 1. If you put a circle around those with those 2 points at the end points of the diameter, then of course, we need the line to have, we're looking for the line x equals 5, but there are 2 points here that are going to make a right angled triangle based on the circle theorem about right angled triangles along the diameter like this, right? So this will be a different place to before because the right angle is being constructed here rather than here or here. So we're going to have a point here and a point here that's also going to make a right angled triangle in these 3 points here. Of course, all I need to do here is just say, well, let's work out the equation of this circle, which is this, because I worked out that the distance between this point and this point is 7 squared plus 4 squared, which is root 65. Just halved it, and that'll give me my radius, and then, of course, square it because that's the formula of a circle. And now, of course, all I need to do after I square this out, all I need to do is put in 5 and k to work out my 2k values representing these 2 points. And of course, you can solve this. It's not too bad. This ends up being a quarter, which is very helpful because when you remove a quarter, you get 64/4, which is 16. Square root to get plus or minus 4, and then you have these 2 answers. And those are the other 2 k values you can use. Now sum all the possible k values. If we add up all of these 4 things, we'll end up with 2.25. The plus and minus 4 cancel, so that's all good and goes away. Some more nice questions here. The first thing to say about this question here is if we just ignore the other circles and just look at these 2 in the middle, this gray area is completely independent of where you put this white circle, as long as the circle is entirely contained in the gray one. For example, if you move this circle around, you can just see, as long as you keep the circle within the bounds of the black one, the area of this black region cannot be changing because you're not doing anything to, you're just taking away the same area, right? As long as you don't do this, the black area is the same wherever you put this. So the fact that these circles are not concentric doesn't matter, completely irrelevant. You don't need that at all. So, okay, that's fine. We can work out each area individually then. So, well, okay, this area, if n is 1, I can work out this circle is just by putting n as 1 in and moving these 2 things over and completing the square, taking away 1, adding them together to get 2. So this is a circle radius root 2. But of course, when you do pi r squared, that's just going to be 2 pi, area 2 pi. So this circle has area 2 pi. That's r squared, right? So pi r squared is just going to be this times pi. Now the bigger circle, that's when n is 2. You put in n as 2 into this, you get this. Take these both away and complete the square. Minus 4 squared gives you an 8. Sorry, minus 2 squared gives you 2 lots of 4, which is 8. And so this area is 8 pi. And now, of course, this gray area is going to be the big area, which is 8 pi. Take away the small area of 2 pi is 6 pi. Do the same for the next one when n is 3. and do the same. Notice that this number has actually got a pattern here. It's just double the squares, double 1, double 4, double 9, because of course you're just getting two square numbers and putting them together over here when you take away the square bit from computing the square. So, okay, that's area 18 pi, and the next one, same thing, is going to be minus 4 squared minus 4, sorry, yeah, minus 4 squared minus 4 squared, because U32, again, double a square number. So it's going to be this minus this. But that's where the pattern's going to come from, right? The pattern is going to be, we're going to do, to add up all of these, we're going to do two lots of the difference between two square numbers. So for example, this is 2 squared minus 1 squared doubled, and times by pi as well. And this is 4 squared minus 3 squared doubled, again with a pi. So this is the kind of the pattern, is it's double the difference of the squares every time, all the way up until the last circle, which is 100 to 99. With a pi outside, you can factorize out the whole 2 as well. And now you can do some difference of two squares here if you want to. The reason that this is helpful, I guess, is that every single one of these first brackets is going to be 1, of course. And then you're just adding together a lot of numbers. This is going to be 3 plus 7 plus 11, and so on. You end up with this pattern. Of course, the pattern works because you increase this one by 2 to get to there, and also this one, so you increase the whole sum by 4 every single time. And now we just need the sum of this thing here, which is just n over 2 into 2a plus n minus 1 times d is the formula I've used there. There are 50 terms, of course, because there are 100 circles and you're using 2 of them each time, so that's 50 terms. And you just do some calculations and you end up one way or another with finding that this will be your answer. So yeah, good to go. Question 18. So we're adding up another infinite series here. So and the a is 4 and r is 2k over 7. So it's going to be this, which we can, of course, combine together and put the 7 up there for this. However, we should make a note that this only works if 2k over 7 modded is less than 1. In other words, if you times by 7 divided by 2, if k is less, or mod of k is less than 7 over 2. So, okay, we can't go up to 5. We have to stop at 3.5, and we also have to stop at minus 3.5. So, okay, that's the first thing I'll say. But also, then we actually need to say, well, this is the sum to infinity if this is true. Let's just make that bigger than 3. Now, I can actually get away with just timesing by 7 minus 2k both sides here. The reason I can do that is because if the mod of k is less than 7 over 2, then this is always positive. So usually you can't do this with inequality because you might be timesing by negative. But if this is true, which it is for any of this to make sense, then I can just be lazy and do that. Expand this out and rearrange, and you end up with this. So k has to be bigger than that, but it has to be less than 3.5. And okay, k also has to be an integer, so it has to be minus 1, 0, 1, or 2, or 3. This is completely pointless. I only wrote this earlier when I didn't notice that k had to be an integer. Just ignore that. So, okay, well, that's 1, 2, 3, 4, 5 out of 11 possible integers it could take. So that's 5 out of 11 is our answer. Good. 19 then. So firstly, I just thought I'd split this out. So dy by dx is this piecewise function. It's just 6x if x is positive. Because if you put in x as positive here, you get minus 6 times a positive number, which is minus something. And then you mod it to make a positive. So it's just doing this if x is positive. You're just going to get a positive number. If x is negative, you put in a negative here, and you get minus 6 times negative is positive something. And then the mod does nothing. So the mod can just go away, and you're just left with the inside if x is negative. Or looking at it from this point of view, if x is negative, this makes like positive something, and then great, because dy by dx is always positive because of the mod. So that's that. Now I can differentiate separately, and I'll get these two, integrate separately. I'll get these two functions when I integrate. Don't really care about the plus c, because we're only being asked about f of x. I just need to decide how to write f of x as a singular function. It's clearly going to be one of these two answers, right? And what I decided to do was just draw it. Like this function, if x is positive, is just 3x squared is just this bit of the x squared graph. And if minus 3x is just the upside down x squared graph. So it looks like this. So yeah, it's clearly one of these two graphs, but it's also just clearly this one, right? Like if x is positive, we just have the 3x squared graph. So this the mod does nothing and you just get 3x squared. If it's negative, the mod needs to make this whole thing negative. So this will be the right graph here. And the answer, I think, is definitely D. Good. And finally, for question 20, this is the graph f of x. The graph f of x all squared. Now, okay, let's just do this step by step. If x is very small and, if f of x, which is of course the position on the y-axis of the graph, if f of x is very small and negative, that's going to square to be something very small and positive. And likewise, this is going to square to be something very small and positive, and so on, until these slightly bigger numbers are going to still square to be positive, but they're going to square to something a bit bigger each time. There's going to be a point where this is at like -1, where it's going to square to +1. And then, of course, -2 is going to square to +4. So it's going to get much taller up here. And then it's going to quickly come down as you square smaller and smaller things down to 0. You're just going to get smaller and smaller things down to 0. And on this side, the same thing's going to happen, except it's just going to be positive still, because when you square positives, you still get positives. So this is the graph of, I haven't even bothered to put anything through it, but this is the graph of f of x all squared, right? Very roughly. Now, what's the maximum value of f of x squared minus f of x? Well, if you look at this point here, f of x squared is 4. And so 4 minus 2 is 6. So I think the maximum, we can think of it as the distance between kind of my graph here and their graph. The maximum distance is 6. So that's the maximum value. What about the minimum value? Well, it can definitely have the value 0, because like here maybe, where this point is at 1, 1 squared is 1, so the graphs are in the same place. So this can definitely have the value 0, but it can also have a negative value, because sometimes this graph is beneath the other graph. This graph is actually in a higher place. So this can actually be a negative value. For example, if you take the point like somewhere a half on the original graph, that's going to square to be that same x value a quarter on the new graph. So therefore we'll have this value be minus a quarter. So there is a maximum difference of 6, and there is a potential minimum difference of minus a quarter. Now, I don't know that that's the furthest apart that those two graphs get, except I kind of do, because when I look at the answers, here's the value of 6, which I know can't be the maximum difference between the maximum and the minimum, because I have a difference of 6 minus a quarter to make 6 1/4, which is this answer here. But it can't be 8, because that's these graphs, the square graph is not ever 2 below the original graph. So we can't get to 8, and we certainly can't get to this. So I think F must be the answer. And that's the whole thing. Thanks for watching, and I'll see you next time.